Hello, Internet. So I've added the next set of planets, and there we go. So you can see a lot more grease and more planets, and then the output goes like this. We get some autofocus going on, and you saw in the previous smashing of videos that these pegs were failing in the first version of the gearboxes for Rover V2. Now, in my previous robots, I have not had any failures here. So I was pushing pushing the gearboxes really hard, and I made this two-stage gearbox. So there's a single planetary stage in here coming off of the motor, and then that feeds an output plate which has a new sun gear on it that goes up into the planetary stage here, which goes into this output plate, and then this beautiful cover will be screwed on here, and then you'll see it looks kind of like something from Mario, but it's the gearbox for Rover V2, and this is the new gearbox. So this is the output spline, and then you can see these bearings rest here, and this heavy duty unit is screwed to this ring gear, which is also screwed to here. So you have a dual supported wheel with an output shaft. Voila, this is the gearbox for Rover V2. So let's spin it up. So using the built-in control system on the controller to go at a relatively low speed, and you can see it spinning. It can be a little jerky. I have a different control system for Rover V2. Although if I bothered to tune this one, it would be fine. There's nothing wrong with the control system built into this controller. Lots of extra lubricant. So last time I learned that not including lubricant caused my gearbox to fail. But we'll go a little faster to 5,000, so 3,000 RPM. Cool, looks good. Let's go to 10,000. I'm gonna make it real noisy, piss off the neighbors. And I'll just stop there. We could. We'll try it. Let's go faster. Okay, yeah, so it can go fast. Plenty fast for this thing, but instead of being a 4.3 to 1 gear reduction, it is two 3.3 to 1 gear reductions, which is an 11 something to 1 gear reduction. This is the new gearbox. Since the wheels on Rover V2 are much larger diameter than the tires on Rover V1, the increased gear ratio will help us get the torque that we need to move the thing forward. It's also a heavier robot. And I have higher expectations for V2, so this extra torque will be very nice to have, and we can easily get a higher gear ratio if we need. This is actually a relatively low gear ratio per stage with much larger gear teeth than I think we need, just because the 11 to 1 reduction I thought would be a good place to start. One of the things I love about these 3D printed gearboxes is you come up with any ratio you want, and it prints all the same. So it was really easy to go from a 4.3 to 1 to an 11 point something to 1 gearbox. It just took an evening of refiddling with the files. And then, yes, the other thing I was going to say was these are 14 millimeter diameter 3D printed plastic pins coming out of the planets right here. And the pins failed in the previous videos. So I've looked at McMaster, and it's it's relatively affordable to get some alloy steel dowel pins that would go in these, and instead of printing the gears with a boss coming out of them, I could print them with a bore and stick a pin in there, and have steel pins coming into here, which would be extreme. The pins are very smooth, so there'd be less friction, and they're very hard, so they're not going to wear away. And I think it would dramatically improve the life of this gearbox if we do continue to run into problems with the printed pins. So, yep, that's all I got to say about this. And I think the next time you'll see this gearbox with this cap on it, I'll have a wheel over the outside, and we'll be driving it around. Wish me luck. Wish Rover luck. Thanks.